continue with question number 6, please. Let's begin. So the coordinates, a curve is such that dy dx equal to this thing. Okay, so that means dy dx equals to, it's good to copy it. As you copy it, you get the feel of the equation, 2x minus 3, then whole square like that. So given that the curve passes through the point 3, 5, so comma, 3, 5 are coordinates, find the coordinates of the point where the curve crosses the x-axis. So what we do is we write it like this first, in the power form, minus 3, and the power is minus 2. Okay, and then here we have it. So y equals to integration of 6 2x minus 3 power of minus 2 dx. So we're trying to find the equation of the curve now. So we're integrating, we take out the constant like that. So the power is just plus 1. So it becomes minus 1, minus 2 plus 1. And then we multiply us by the, actually it's divide by the differentiate inside. So it's 2 like that. Then plus c. So shortcuts lah, how people actually do it. So at this point you also know just so it becomes 2x minus 3 power negative 1 plus c. Okay, we put a line here. You can always double check by multiplying in reverse. So you times the negative 3, then minus 1 become minus 2, then times the differentiate inside is negative 6 then. Negative 3, this one, 2, negative 6. Yep. Oh, I think I made a mistake. I didn't divide by the negative 1, right? Negative 2 plus 1. That's why the thing is missing a sign. So it should be a negative 1 here. Yep, because we would have, oh yeah, the negative, wait, sorry, confused myself. Yeah, when we integrate plus 1, we need to divide by that. Yep, because we have multiplied this one. So it becomes a minus 3 in front. So always double check like that, please. So sometimes good to double check. So positive 3, then times 2 is 6. Okay, minus 2, correct. And then here, what we do is we rewrite it as y equals to, easy to see lah for the eyes. Sorry, negative 3. Keep forgetting the negative sign for some reason. Okay, 2x minus 3 like that. Bracket is not necessary, just for emphasis. Okay, let's just put the x equals to, just tells me that the value of x is 3 and the value of y is 5. So we just substitute. All these are just to calculate the value of c. Please take note of the reason now. And then here it would be 2 times 3, minus 3 in the bracket, just to show it differently. So this become 5 and then plus with, let's simplify this, 3 times 2 is 6, 6 minus 3 is 3. So 3 is minus 1, so plus 1 is c. So c turns out to be 6, just normal equation solving. Okay, now what we do is we try to figure out what they ask, but good to write the equation at least once. Just copy the topmost sentence there, 3 over 2x minus 3 and then plus 6. So just the equation of the curve. So it passes through this point and then we found the curve already, the equation in full. So we just need to find the coordinates. Now we're doing this part, the coordinates of the point where the curve crosses the x-axis. Crosses the x-axis means y is 0. So in other words, we are looking for x-intercept. Sometimes we use the word x-intercept or intercept if there's 2. And then it's same as telling y equal to 0. Okay, let's put the y equal to 0 and same and try to solve it, please. Minus 3 over 2x minus 3 plus 6. So 3 over 2x minus 3 like that goes to 6. Okay, so you bring like that, it's equal to that. Then you times here and here. So same as 1 here, 6 over 2, 6 over 3, 2x minus 3, bring that. Anyway, you can solve this linear equation. So bring it like this, all this. Okay, so this is like that. And then we realize there's only one coordinate. The coordinates of a point. It's only one point apparently. So x is 7 over 4. So I'm too lazy to write a fraction. So I just write because decimal is ending. So it's good to write that 1.75. And then one last thing, we just change this 1.75. We need to find the corresponding y coordinates, which is not necessary. y is 0, 1. We know that. So the coordinate is, the answer is 1.75, comma 0 on this. Thank you.